So now we're on with discussion of the EPRV roadmap leading by Jan and Heather. So I'll have them to you.
Exactly. We verify that folks can hear us online. We're good? Okay. Okay.
Yes.
Yay! Okay, so last presentation of the conference. I hope you all enjoyed your coffee and tea and have a little bit of energy left, because similar to the other sections, this is going to be one where we're asking for a lot of input from you once we get through this kind of quick set of intro slides. But yeah, so Heather and I wanted to talk a little bit about the EPRV roadmap, what we think the important next steps are as a community to move towards this goal of whatever you want to define EPRV as, whether that's 10 centimeter per second precision, 1 centimeter per second precision, the ability to find and characterize certain types of planets, to mitigate stellar activity to a certain level. I think there are a lot of different ways that this phrase has been used. We would all love for it to be a well-defined, pre-vetted route that we can take. I don't know that that's really what's going to happen. I think more so it's going to be us in this room and groups and communities around the world hacking our way through the jungle of stellar activity and funding needs and facility construction over the coming years, but I think we're up to the challenge. So a lot of what I'm going to point to is going to be somewhat NASA-centric, because that is the agency that I work within and think about the most. But we take all of this as very generalizable to any country, agency, etc. that you are involved with. But in general, I think it's a true statement that over the last decade, there's been a lot of enthusiasm for exoplanet science and many flavors of exoplanet science. So we saw this in the 2010 Decadal, which is the big community document that comes out once a decade and tells NASA, here's what you should care about and here's what you should fund over the next 10 years. Where back in 2010, we already knew that observational challenges were going to be large, but that I like the optimism here. Like, astronomers are poised to rise to that challenge and move us forward into exciting areas of exoplanet science. So this is great. And then even more specifically in the 2018 strategic plan, thank you. Encouraging language. We want to find habitable environments outside of the Earth. This is NASA's big focus of looking for temperate terrestrial exoplanets and trying to decide if they are habitable. This is coming to fruition as we move towards having a flagship mission, probably in the early 2040s. That's going to do direct imaging of Earth analogs as the goal. And so that is now a big focal point. And so we knew that, there are a lot of techniques and ideas and abilities that need to be improved as we move towards that goal. But again, we're poised to rise to this challenge. It's going to be great.
And I just wanted to say a small note about things being done in the UK. So Annalise and I put together a white paper and has a lot of UK community support for it, kind of just sort of preaching this same point that it shouldn't just be NASA and NSF that come up with a roadmap, that we want to be part of it as well, and that actually we need to liaise with all sort of different international bodies from ESA and ESO to NASA, NSF, and beyond. And this white paper we're hoping is going to influence the UK's roadmap for astronomy research, so we're still waiting to kind of see how much influence we have had. And we have the slides here that Jen has linked them in the Slack. And so you can access the white paper from this link. And if you haven't actually signed it and you're a UK person, you could sign it still. If you want to sign in, you're not a UK, maybe just open another tab or put yourself in another column or something. Because the more support that we can show for this initiative, the better.
Yeah. So we've been working on this concept of looking for Earth analogs in a couple of fields, most predominantly transits and radial velocities. We haven't quite managed it in either one yet. So this is a map of occurrence rates and detections in the Kepler field, looking at 4 years of data around G-stars. And if you look at one Earth radius on a 365-day orbit, these gray squares mean we didn't find anything here. So all of these numbers are extrapolations from nearby squares, but Kepler didn't actually manage to find us. So maybe people are still digging through that data. There is maybe hope still. And then in a similar vein, we've seen this plot a number of times so far this week, but RV detections. The Earth is down here with a semi-amplitude of about 9 centimeters per second. We've seen, again, this bit of a tail off around 1 meter per second. And so we've got some work to do in either direction looking for the Earth. So the basic argument, like I mentioned a moment ago, to NASA or the funding agency of your choice has been for us, we want to directly image Earth analogs. We want to know what their atmospheres look like and if they're actually similar to our planet. In order to take those direct images, those direct spectra, and interpret them correctly, we need precise masses. Because if you don't have a precise mass, your retrievals are going to be dominated by the uncertainties in the mass measurement. Probably 2 ways to do this. Very precise astrometry or very precise radial velocities. Neither of these fields are currently at the precision level necessary to find an Earth analog. So no matter which fork you choose, there's a lot of development work to be done, a lot of effort needed by the community. But astrometry at this level has to be done from space. You cannot do it from the ground. And so that suggests that it is going to be something like $1 billion mission that's going to have to fly somewhat simultaneously with your flagship, and that's a lot of investment. Whereas there is still a chance that EPRV could solve this from the ground and potentially for an order of magnitude less money. And so all things being somewhat equal, it makes sense to pursue the cheaper and more flexible option first. And so we need a lot of effort still, but EPRV seems like the first road that we should go down and see if it is possible before throwing our hands up in the air and saying, just kidding, actually build a space astrometry mission.
And just to add to that, the idea of trying to get the masses beforehand, that's not really possible with an astrometric focused avenue, because then you still need to build this spacecraft that doesn't exist yet and then fly it before you fly your direct imaging ones if you wanted it a priori. Whereas this way, if you have the masses from the ground beforehand, you can also improve the efficiency for your direct imaging missions or whatever sort of mission that you're looking at. So it's effective in that way. Plus, I think probably most people in this room would agree that technologically we are a lot closer to being where we need to be through an EPRV route than we would be through an astrometric route.
Yeah, very much so. Yeah, Malcolm?
Just to throw in one more thing there is, I bet when you look at astrometry at those levels, the kinds of things that are messing up our RVs here also mess up astrometry. It's not like you just turn on an astrometry system and you get it.
No, absolutely. Yeah.
Like even if you have all the technology working, it's not obvious that you're not.
Yeah, and that's another, as Heather is saying, to obtain the data necessary to see that that is true and then start working towards mitigating it is a many years lead time. Okay?
Yeah, although just, but there have been simulations are what they are. But it seems to show that astrometry is less affected by stellar signals.
Yes.
Clearly, but the instrument.
What?
Clearly, the stars do not affect the astrometric measurements like
Yeah,
So
but
amazing.
CRVs.
but then it's the instruments, so yeah,
Instrument.
it's other challenges, yeah.
It's also the case that we've been surprised by what the stars are doing. It turns out it isn't all just FF prime. Sorry.
Okay, so with this in mind, God, 2.5 years ago now, 3 years, something like this, the EPRV working group was convened. This was a joint NASA and NSF effort that sought input from EPRV folks around the world. There are a lot of folks in this room who were involved in this, and thank you again for your participation and many hours spent on Zoom at uncomfortable parts of your day because of time zones. But the goal here, as recommended by the 2018 Exoplanet Strategy Science Report, was we should make EPRV science a focus. NASA and NSF should convene a joint working group and try to think about what is necessary to push forward to this level of detecting Earth analogs. And so there is a lovely report that came out in fall of 2021, I believe, that is now available online. I'll put the link to it in the chat in a moment. But as a quick overview of some of the things that the report considered.
I mean, one of the big things that came out was there was a subgroup on stellar variability, and this is, I guess, it's not a surprise to the folks in the room, the tall tent pole. We really need to do a lot of research and analysis on this side of things, and we kind of went through a variety of different physical effects and our understandings and tried to highlight which things we think need the biggest investment. And so that's the sort of color coding here. things that are in red or darker red, it's like, okay, we really need to focus on these areas. They're going to be very important, and this is where our understanding is lacking the most. And then things that are in the lighter colors are like, okay, these are additional effects that we need to consider and may become more important as we get more precise radial velocities, but they're not the like biggest focus here. But that was just kind of like highlighting here. It's probably not a surprise. I mean, one thing in particular, not just the faculty, but really our understanding of stellar line behavior from a fundamental level, and getting those solar and stellar theoretical physicists like in the room with us, and getting that knowledge that exists in the 70s and updating it to the 2020s, I think is going to be very important. We did come up with sort of a plan about what we think the next 5 to 15 years should look like in terms of our efforts in this realm. So this is a terrible slide in the sense that, like, I don't expect you to read it either. You can take a screenshot or just go and look at it in the report. But the idea is kind of in the near term, we'll probably mostly be focusing like quite a lot on the solar data because it's quite rich and it's where we can get the most information out at the moment. And then as we transition to the long term, sort of figure out how that knowledge transfers and what knowledge does not transfer, and then how do things change as a function of effective temperature and surface gravity as we move out, and sort of just kind of looking at, okay, in these near term things, we need sub 50 centimeter per second RV precision, and to really look at this like high cadence. And then towards the end, we would really like, you know, a couple centimeter per second precision, and then looking at, okay, what can we understand at these time scales. And we also went through and said, okay, what do we want the instruments to look like in this sort of beautiful EPRV roadmap world? We do need high resolution. We need at least 100K. There's probably going to be diminishing returns after maybe 300K. It's still something to explore, but resolution is important if you want to use the asymmetries of your line as any sort of diagnostic, whether you're using all of the, like you're operating in 2D space and using all of the like spectral lines, or if you're operating on some sort of activity indicator or whatever, the asymmetry and the line behavior is important, so we need to resolve that. Signal to noise is hugely crucial. It's nice to see that our goal of over 300 matches well with what Mikkel showed us about that number of 250 being quite important. So that's we're in agreement there. We'd really like to get a signal to noise of 800 or 1,000 and really like bump that up there. Spectral coverage is huge. 380 to 930 being kind of a minimum, but like potentially if you can push out further into that near infrared regime and then start to get more of that information from the like how things change chromatically, that would be quite great. And then if we can, we want uniform coverage and longitude in both hemispheres. So this is again thinking about it in like a roadmap framework. Okay, where are existing facilities and how can we connect them and how can we bring the community together, and what facilities don't exist yet that should, in terms of like trying to put up this coverage map, and do we need to refurbish things, or do we have to build new? And we were saying, okay, going back to that solar stellar knowledge and what is the richest data sets, all EPRV instruments should have a solar feed on them. It's crucially important both to understand what the stellar variability is doing, you know, because we can study it from the sun and then hopefully figure out extractions from there. But also we saw a little bit of those overlapping baselines between different instruments, and these solar feeds are going to be probably very important for us to understand the instrument response. And keeping in mind with that, we also want to think about like, okay, if you have a different instrument, it has a different passband, you're looking at sort of a different set of information there, and how do we map that together? Well, if we have overlapping baselines, we can get a little bit better idea on that. And then of course we want to improve the precision for the near infrared. I think we kind of all know that we're lacking in terms of stability there, but let's get there, and in particular looking at the telluric side, which is really important when you move to the near infrared. and then having a high stability visible band calibration source to better than 1 centimeter per second.
I see the hand. What's up?
I just wanted to say, I've been thinking a lot about resolution because stars, of course, have finite resolution. So from a pure radial velocity perspective, you might say, well, you saturate pretty quickly because once you're resolving the star, you're resolving the star. But one thing that came up in this meeting more than once is that it looks like it's important to understand the depths within the star that the flux came from. And that's just way more precisely known at higher resolution than at lower resolution.
Yeah, definitely.
And so I've become a converter this week I'm converted now this week that we must go to high resolution. But I think it's not just the shape of the profile, it's about characterizing the physical origin of the.
Yeah, definitely.
I clicked it. Make it again. Yeah. Okay. In addition to the instruments, again, this is a wall of text. Please don't read it right now. But there was a lot of thought and effort put into what should EPRV pipelines and data analysis efforts look like. And this includes both recommendations for what the pipeline should include, how they should be vetted, how they should evolve over time, how we as a community should interact with EPRV data as it comes out.
I think maybe that one takeaway from this as well is that we want these things to be open source.
Yes.
And to share all of that, all of the data products. And that was like one of the big pushes. And I think this comes back again to the discussions we had earlier in the week about like this being a collaborative effort. And like if we share all of the data in that sense that like we can get more of it out as a community.
Yeah, and that just being handed an EPRV time series nowadays is insufficient for the type of work that we're trying to do. You want all of those raw calibration frames, potentially the 2D spectra, so that you can work from anywhere within the reduction process. We were really optimistic. We had all of these ideas of different types of architectures that we could put together, combining different apertures with different instruments in different parts of the world. There were a bunch of simulations that showed in these very idealistic concepts where we fix stellar variability and there's just kind of some white Gaussian noise in there that we can indeed find Earth analogs. And then there was also a great bit of work done trying to figure out what the computational needs are, because as we've seen with people quoting the number of hours or days or weeks that it took all of their analyses to run this week, it's an intensive effort and that's something that needs to be funded and supported over long time scales.
Do you attempt to do that for theory?
No.
Yeah, it's very interesting because it's quite hard to estimate what you would need theoretically.
Well, I mean, from the solar variability group, we did our best to do that.
right?
Yeah, we did. That's why there's person power in there. And when we talked to different experts in the field, we thought, okay, if you had like X number of PhD students or postdocs working on this, like what is your best
years of
estimate
someone's time? It's all calculated.
Yeah. And like, okay, if you think about your ideal scenario there, what computational power would accompany that theory? So it could be 1 orders of magnitude off. Our best guess here.
Like PMOs, 10 months. No big deal.
Can you give me like 2 sentences on how those estimates like, were made?
We kind of went through and said like, okay, what do you think that we would need to solve this? Like, for example, one of them was like, okay, it would be great if we had an MHD simulation of this long and it had like this many spectral lines synthesized and it had this many different magnetic fields, you know, like we did it in these different things. And we went and said, okay, and now let's extrapolate that to different spectral types and stuff. How long would it take you to analyze that and construct that kind of thing? So that's like one element of that. Yeah.
Things are happening on Slack.
Can I ask that we get through the last like 3 slides?
Yeah, no, I agree.
To that?
Fair enough.
Otherwise, I want to get to the part where we're asking for everyone's input and I'm typing it. So I don't want to lose these ideas. Okay, one of the roadmap that came out of the working group looks, because NASA just loves Gantt charts. Looks something like this. It's a nicer version of a Gantt chart, but gave this kind of 15-year timeline as like, here's what we should be doing with observations and with data analysis efforts and with technology development. And again, very broad strokes here. but you can see that every one of these topics has a number of action items that span many years, and they're all interwoven with one another. So at any point in time, there are things happening in all of these areas. So ambitious roadmap that came out of the working group. We submitted this to NASA and the NSF, and they said, thank you very much. And that was about it. NASA had a poker face.
There was a NASA Roses call that came out
That's true, actually.
before the final report was even out. So some people are listening.
That's a valid point. Yeah, so we worked really hard to go to NASA and say, this is really important. And their response was they had a $1 million or so Roses call, very focused on stellar activity, that came out a year ago. There were 8 PIs selected for that who are now leading 8 different investigations into aspects of mitigating stellar variability, using everything from solar data to SDO images to heterodyned observations of the sun, I think.
Yeah. So we were very hopeful for this decade.
Yeah. And so then the next decadal came out. This came out a couple months ago now. This is the 2020 decadal that came out in 2022. But it is good for the next decade. This is the community saying to NASA, here are all the things that you should prioritize and care about and fund over the next 10 years. And those of us from the working group opened that giant document, Control F for EPRV, and found very little, which was upsetting to us. There is no mention, no specific mention of EPRV in the first 7 chapters of the decadal, which are the chapters that NASA actually has to respond to and be responsible for looking forward. This does not mean that NASA has forsaken EPRV, that the people at headquarters will tell you that's not true. It does mean that the decadal is not something that we can point to and say, obviously this has to happen. So we now need to advocate and say, this is why you need to care about EPRV efforts. So at the moment, again, I'm very NASA-centric and I apologize for that, but NASA's big goal is to build this direct imaging flagship mission in the late 30s, early 40s. The concept is that the time to start building it is not now. Now is the time to do precursor science, science that will help inform what the architecture of that mission looks like, how it should be operated in order to give us the best chance of detecting these Earth analogs around bright nearby stars. These are subject to change, these definitions, but what we've been using is a precursor, as you see here, where like Rose's efforts, Rose's is the big funding call in the US, are going to be for precursor science, is observations that are required to set the architecture of the mission. Preparatory science are observations that are necessary to help fully realize the science potential of the target that this flagship observes. So over the next few months to years, we're going to be focusing on precursor science. And so our job now is to convince NASA that EPRV is an important precursor science idea. Okay, so this is the bulk of what we want to get to, is to chat with you all. And I'm going to be taking notes in a moment. There's a link in the Slack channel for day 4 discussion to a blank, currently Google Doc that has what we should be doing in the short, medium, and long term. I have some possible ideas here that I will move over, but then we want to hear from you all. So short term, number 1, attend the all virtual and on Zoom NASA Precursor Science Workshop that is happening later this month. This is a 3-day virtual workshop where basically the community gets to show up and work in small groups and then come back to NASA and say, here's why insert your science here is important to the flagships. This is for all of the things NASA wants to do, all the big missions over the next 3 or 10 years. So this is not only the direct imaging flagship, this is also the FAR IR probe and the X-ray mission. So we're going to be up against a lot of other astrophysics fields. And so more voices, more viewpoints saying, here's why EPRV is important would be great. And then to work towards developing the infrastructure to support more continuous conversations, because I think we've all in this past 3 days seen the value and the importance of keeping up with what everyone else in the field is doing. And nowadays, we're in a wonderful state where there's a lot of things happening in a lot of places, but I think it's easy to miss some of the efforts and to miss possibilities for collaboration that would really help move things forward. So shameless plug. One of my jobs in my new job, or one of my responsibilities in my new role at NASA is to set up an EPRV research coordination network.
Which is something that came out of the final
It
report.
was. That was one of the
Basically,
recommendations.
we said like, okay, you have coordination networks for these big space missions, and we are going to need a similar level community effort. So we should have this for EPRV.
Yeah, so the recommendation from the working group was that, EPRV is like a mid-X level mission. It's $100 million to figure this out over the next N years. That requires some level of coordination. And so I'll put the link is on the slides. I'll put it in the Slack channel in a moment. Right now, there is a very bare bones website, but this just got started about a month ago. I'm running it, and the goal is to have monthly science seminars, regular discussions, a steering committee that helps to establish focal points, possibly things like working on, like white papers that the community could contribute, assigning task force to work on these different things. And so having input from as many people thinking about EPRV as possible would be a huge advantage. And I think the more people involved, the stronger and more effective that coordination network becomes. So I will ping all of you on Slack until you join.
And my sort of shameless plug to those outside of the US is that, like, we don't want this to only be US led. We want to remain part of this. NASA has a lot of money and they're going to continue to fund this. We don't want to be left behind. So let's join and let's all talk together and make sure that you do become part of this.
Yeah, I think it's been so obvious from this week that I would maybe even a majority of EPRV efforts right now are definitely not in the US, certainly a giant fraction of them. So I would love to have all of you involved. We want this to be a global coordination network if possible. It just so happens that NASA is willing to pay someone to run it. So, okay, second shameless plug again for that UK roadmap that Heather mentioned earlier. Links will be in the chat.
Already on Slack, people are already signing, so.
And then Nathan is going to put something in the Slack. Do you want to say something now?
Yeah, well, sure.
Go for it. Yes.
Did you want to say something before?
No, go ahead.
Yeah, it's just Eric Ford and I are writing a review on statistical methods for RV analysis, and we wanted just to present the general outline of the work and ask you if you have any thoughts on what could be missing. And so the first part of the review is aimed at non-specialists. So basically, if you have a grad student who knows nothing about RV analysis, you can point it to them. So we organized it in a sort of way. So we start with detecting planets and estimating orbital elements. So we talk about periodograms, Bayesian, Poisson, and so on. Then we move to specifying the likelihood and priors, like what would you typically choose? How would you model activity with the Gaussian process and stuff and like this? And so the part the people in this room are interested in is the analysis methods at deeper levels in the spectrum. And here our job is not to do express challenge, to redo the express challenge. So we will rely a lot on this. But we will try to find a sort of underlying theoretical framework of the different methods of the express challenge and the current advanced methods. And yeah, so I don't want to take too much time, but if you see that's something which is obviously missing, feel free to contact us on Slack and send us your favorite paper, something.
Do you have an open manuscript that people can look at?
Not yet, but yeah.
Just send around around on the Slack that table of contents so we can take a look at it.
Yeah, sure. Okay.
That's a great thing.
And then can I get through this?
Yeah, sure.
Okay, so yeah, things to do like today or on your train/flight home, those top few. Medium term, more events like this that are encouraging discussion and collaboration within the community. I think especially events that are open to work in progress efforts, lessons learned, failed efforts. When we're giving conference abstracts, there's this idea like it has to be very polished and like here's my shiny result. I think we all benefit a lot from having an open and safe space to share. We tried this thing and it didn't work very well. And so does anyone know why? Or maybe don't try that yourself. Save yourself the pain and effort and do something different. Things coming up soon. There's going to be an EPRV splinter at Exoplanets 4 that Johanna Teskey and I are organizing. It is going to be virtual. It does not require you to be registered for the meeting. It is a separate event. So I will put the sign up for that in the chat Slack as well. we are soliciting abstracts. They're going to be due by April 8th. And so if you have an abstract, send it in. Even if you don't get a talk, please call in anyways, because we're aiming for it to be very discussion focused. It's going to be 3 hours long on Tuesday, May 2nd, I think. There's a similar, like 4-hour seminar session at Cool Stars 21 that I think Louise is in. Some people in this room are involved with this. Annalise, okay, wonderful.
Aries as well, myself.
Okay. Yeah, so that's a new way. It's EPRV 5. We are aiming for spring 2023, somewhere in Southern California, probably Pasadena.
Before EPRV 5, though, there is the UK National Astronomy meeting happening July 11th through 15th. There's 3 different exoplanet footage there. One of them is on stellar variability.
A general goal for the RCN website that I'm working on designing is going to be a list of like, here are relevant conferences and workshops to attend. So yeah, so I will be transcribing all of this. Deadlines are 2, GPRV 2, hopefully in the coming year and a bit, as we heard.
Yes.
So on GPRV 2, if somebody can think of a better name. I just want to say I'm not wedded to the name. Like, please use your creative powers and send it to Xavier and me and stuff. We really would love it if it had the words data analysis in it. And I spent about an hour between sort of 11:30 and midnight last night trying to come up with something. And I did not come up with anything that was.
We will backronym this with gusto and figure out something clever.
And just a word about the Know Thy Star. So some of you may remember there was a Know Thy Star, Know Thy Planet conference a few years back now in California. I think it was mostly spearheaded by David Ciardi at the time. And David has approached Raphael Haywood and myself about doing another iteration of that. Our plan at the moment is for that to be in Europe, possibly at the University of Warwick in July 2023, pending some funding outcomes. So that's sort of the thoughts there.
Yeah, so one of my goals is to have a running list of all relevant meetings, workshops, et cetera, on that RCN website as it gets developed, and so that'll all show up there. Other things to do in the next 2 years, talk to more stellar and heliophysicists. I think that's been a recurring theme of this meeting. I think a lot of that is having not just a talk from someone, but the time to develop a shared language and understanding of what data products do we care about and how to explain that clearly to them, and then have them come back and say, here's what we know and how it could be useful to you. And so I think sustained conversations are going to be really critical. And then again, this idea of, are there white papers that we should be drafting? I was excited to suggest this idea, but worried that people would be like, oh, homework is terrible. And then you all brought it up yesterday. So you assigned it to yourselves and I will leverage that fact. But I think it's worth having, an ongoing discussion about this as well, of what topics could turn into white papers and which ones are valuable that we could point to in future funding, observation, et cetera, proposals. And then long-term, this idea of having collaborative surveys across a variety of facilities and instruments to obtain the data we need to move EPRV and stellar activity mitigation efforts forward. Communal science platforms. I mentioned this idea of a public EPRV pipeline testbed where you can come and plug in the bits of your pipeline that you want to test and see how it works. Shared archives for solar data where it would be easier to say, I want every solar observation that was taken on, July 2nd, for example, and have a way to pull that from NUID and, the HARPS North data as it becomes available. And if Express solar data becomes shared with the community. So efforts like that. And then at some point, when do we start pondering the next generation of EPRV instruments? I think we're all still learning right now from NUID, Express, Espresso, HARPS 3 as it comes online. But what is the time scale for saying we've learned enough from these that we think we could do better and we should start putting some of those ideas into practice? Okay, so with that, the last 25 minutes of this presentation, we have a right now very blank.
Do you want it to step?
Oh, sure, yeah. I'm going to ask you to manage the room.
Yeah, point.
And I'm going to type.
Sounds good.
And no one's allowed to mock my spelling. Yeah, so those were a couple of possibilities, things we should be thinking about. What we'd love from you all is what else should go on this roadmap?
Is there questions from the Slack that need to be addressed?
I would say it was very specific and it's been discussing already there. So
Okay,
say
okay, all right. Does anyone want to add something Anyone want, like, you can click this and start typing your own self as well, because the slides are available from either Teams or Slack.
Yeah, it's in the Slack channel, but also bit.ly/EPRV_roadmap_GPRV 2022.
Were there some Slack questions that they get asked?
It sounds like they were more technical and they've been responded to in Slack. So we're gonna-
There's a discussion on the signal to noise and telescope size and how to get to 800 signal to noise. Because, I mean, if we're going for the Earth twin, I think the likelihood that it happens in a magnitude 4 star is very low. So we are going to need to have like an express something like that instrument in a telescope that can give you the signal to noise in a magnitude 10, 11, 12 star, and that you can do mostly dedicated surveys. So at least at the IAC, we've been thinking about this problem for a while, and our opinion is that we need to build smarter telescopes that are like good at what we do. They don't have any of the other features that you need for general purpose astronomy, and you manage to do them for cheap. But we still don't know what that telescope is.
I think it's a great idea. I'll point out that for the direct imaging focus specifically, because those stars have to be nearby, the faintest stars on the current flagship list are like 7th magnitude. They are all like very nearby G and K stars when we're looking for Earth analogs. So we're actually probably not photon starved, which is nice. But in a broader sense, yes, because there are only 100 stars on that list. There are more stars that we care about and should be searching around.
Suzanne?
Just picking up on the, basically, we just need a big photon bucket idea. Yeah. I'm assuming you're talking to the high resolution planetary atmosphere people because they need the same thing.
Yes, yes.
And one thing that we haven't really talked about much is actually Plato follow-up. So, and that's something that we should be considering again together as a community. Like there is a whole work package dedicated to that, and some of that is assigned in the southern hemisphere with espresso and stuff, where there's a plan for that. The plan for the northern hemisphere is much more nebulous. And so that together as a community, we might want to try to leverage and influence how we're going to do that and work together.
I have a comment. It's a comment though. Sorry. Yeah, on the European side, I think also the second generation instrument for the ENT will be Andes. That has a third of its science cases to do spectral habitable planets.
Oh, Andes.
Andes. So it was used to be called HIRIS. Now it's called Andes.
Oh, I didn't know it had a name change.
I'm so glad
Well, Andes is the actual name now because we just signed all of the papers last week.
There were too many HIRIS out there. So many instruments called HIRIS already.
Yeah, exactly. I was basically we were telling them it's
like some near specs. There are too many.
But just to say that this is also a very big focus of the ENC, and well, the proposed first light will be in the 30s as well.
Okay.
One thing I would love to put in very near term, but realistically near term is we should build an open science. We should build an open science community, so open data and open software, and have people contributing to join. Like the beautiful things that happen in AstroPi and happened in the cosmology community. We should be all part of that, and I think it's totally doable. There's so much spirit around that in this room, and it's very achievable near-term goal.
I mean, and maybe one of the ways that we start taking a step towards that is this coordination network that Jen is leading.
Absolutely, 100%. In fact, there could be a working group within that coordination network for open science. Gladly contribute to that.
Annalise?
Can I ask my tangential question from before? So one of the things that we all want is that we continue to talk with one another. What happens with our Slack channel? Will it stay alive?
It will stay alive. At the moment, it's not on a professional plan. So there is if we reach more than 10,000 messages, then we lose the oldest messages. It might be possible to, there's a monthly cost to having a professional plan.
I think there's a way we could probably raise that.
Sure. The question is basically how do we need to?
I don't know.
It depends if we want to reuse. So if we just want to have it as an archive of what happened during the workshop, we're not at the limit of the 10,000 messages now. We're not anywhere near it. So we can just leave it as is. It will exist forever. People can choose to join or leave the Slack, but it's there. If we want this to become a Slack that we use for other things, then because it already exists, then we should make it into probably one of these. There's a educational version of the professional plan that's a bit cheaper, and that it would probably make sense to find the funding for. And I can certainly fund it until the end of my ERC grant, no problem. And then we might need to find the money for something else. So it to some extent it depends whether we want to keep that and use it in the future, or whether we want a sort of one-off Slack for each meeting.
Yeah, there's an RCN Slack that is also at the moment free, and so it will reach that same message limit. If it gets enough use, I could maybe advocate to NASA that they should be funding it, so it's an ongoing and sustained. Well, I don't know if they would go for it, but I could try.
I quite like the Slack platform, but does anyone have a different preference for another piece of software for communicating across different platforms?
I think for strategy and planning, Confluence has served the test collaboration pretty well, which is like a privatized wiki that you effectively set up in your different pages for different efforts and members who can post here's what I'm working on. And so it's how we currently track what papers are in prep and who's chasing what planets.
I think I'm in a Confluence for something, and I never fully understood it.
That's the only one that I didn't actually get used well.
Data uses Confluence, and it's it's what you make of it. So the problem with data pages is that they're very hard to navigate. It doesn't necessarily have but it's also coupled with this thing called JIRA for tracking documents, which is very useful for space agencies that have all these very formal document requirements. I'm not sure that this community needs that.
Aries?
And you need people to manage it, otherwise.
Yeah, exactly.
It's like my job now.
It's not branded as professional like Slack is, but Discord is literally Slack, but way better and with no message limit. And it has a browser version as well as a desktop one.
And it's free.
The Discord works really well.
It's completely free.
Sorry. Live streaming.
It
We can find tutorials on that. Settings? Yeah.
Different system.
Yeah, it does. I don't understand, I guess because Slack has branded itself as professional, people are using it, but Discord is just honestly way better in every single way.
Ready?
So I absolutely 100% support that. But also, Terra Hunting and Solar Harvest North have been using Alfresco, which it's kind of clunky, but it's an option.
Please no.
Not Alfresco.
I support the Discord point as well. One of the research groups I'm in uses Discord the same way as Slack, and honestly, it's more convenient. It's free. It has the exact same ability to make channels and everything. So,
on this idea of
how long will it stay free?
It's for gamers.
It has a paid subscription model, but you do not. It's an individual thing. You do not need to buy it to get any of the features you'll need. It's basically for people who want extra emojis and other.
Being inspired by this idea of doing different platforms, so I probably should get on the Twitter train, but I'm not. Thinking about this is actually I know it's a way that people communicate science nowadays. Is there a very specific hashtag that we want to think about in order to communicate with one another through that means?
That's a nice idea.
Yes, I think we should, yes. Back on the EPRV hashtag, but we should have some hashtag for it. It should be short.
Yeah.
Could somebody put that URL, the bit.ly URL or the docs URL onto the Slack so that I can click?
It is in the general.
General.
Sorry. Yeah. My bad. Love you.
So I want to raise a point, but I think it would be very difficult to find a solution on Alternative. So you spoke mostly about the NASA view and so on. And there is some good initiative with the EPRV and so on. Then on the European side, the problem is that ESA is not so much focused about exoplanet and doing things on the ground. You were able to convince NASA that this should be the way to go. For the moment, it's ESA. It's not happening. And the thing is that I participate to a lot of NASA proposals, like there was the ROSE things, I participate to a few. There is now these things about this X mission and so on. The thing is, as European, when you are in one of those things, you cannot get no funding, nothing.
Yeah.
And so sometimes it's a little bit, you are spending a lot of time to do those things. And then at one point you say, okay, but is my time really, do I really have to invest so much time? Because in the end, it would be difficult to get something. It will be like big collaboration, but still, you are a little bit on the side just because you don't get funding. So I don't think there is any hope to be able to incorporate like European people in NASA funding because it's not money from the US, but I don't know.
I hear you, yes.
I agree with you, and I have been pushing Gary Blackwood and others to find a means for us to be able to PI things that are specifically connected to the EPRV roadmap. They seem to think it may not be impossible, but we haven't exactly found, like right now, the best solution is, if you can get like a title at a US institute. And so I'm personally exploring like, okay, if I have an adjunct title somewhere, they did suggest like maybe being involved with SETI or something, like get some title somehow connected to a US institute, then you might possibly be able to. But I think that there should be a better solution for that. And we should continue to voice it. We should, I don't know, maybe we need a white paper for that. I'm not sure. We need to somehow be stronger in that. But I think Megan had a point and then we'll let's use.
Yeah, I just, this is a bit unrelated to what Zoe just said, so sorry. But on the note of the open science community, open data, I just want to say that I think the Express Stellar Signals Project / Future Extreme Stellar Signals Project with the solar data are really valuable resources there, and we should make sure not to lose that community that has been built. I hope that can really be an integral part of this collaboration network going forward.
Absolutely, that'd be amazing. Yes. Lily?
I was going to build on what Xavier said, but now I feel like I should be building on
You can do both.
I was just going to say, isn't like an easy way to fix the problem that Xavier was saying is just to make the decision based less off funding? Like, for example, with the RCN, right, aren't all the steering committee members required to be PIs at the Roses call? And it's like, it's not even international, right? Like people at the CCA who are doing a lot of the EPRV work can't get any funding, and it's just like this weird cutoff that means we can't contribute to this research network as much.
Yeah, so that is true. At the moment, the first round steering committee for the RCN is the folks who were funded in that Roses Stellar Activity call. I've pushed back against it enough that we're going to try and recruit a couple of international folks to supplement that and a couple of more like instrumentation focused folks. Because while stellar activity is a huge problem, it is not the only problem facing EPRV efforts. And so I'm trying to broaden that steering committee, and I'm going to keep working on changing the distribution of it over the coming years. But for setting it up, NASA was very keen. I'm like, these are NASA funded scientists, and that's a good starting point. So.
And I think we should, from the European side, push back on ESA a bit as well, because for Plato, I think that is the first space mission where the ground-based bit is actually like a mission deliverable. And so hopefully we can use that as a starting point to be like, look, this is a mission deliverable. It's part of it. So we need to be able to attach ESA funding to EPRV. It's like the door is cracked open a bit and we need to force our foot through and point to this model. Yeah.
That's us with the flagship. NASA does not do ground-based astronomy except for the couple of cases where it does, and that's only when it's supporting a big space-based flagship, so.
Suzanne?
So for this to work in Europe, it only works if ESO is on board too.
Yeah.
For the so that's why it's working kind of a bit for Espresso, because they are vaguely on board. But obviously there's no ESO equivalent in the Northern Hemisphere, so we need to think up a different approach in the Northern Hemisphere. But it's also, I think there is a possible route to gathering support from beyond the exoplanet community for this, is that As Jen mentioned, actually the most interesting targets are actually not that faint. And for example, for Plato in the prime sample, they're brighter than 11. And so therefore, actually, you don't need huge telescopes. And this is a way of gathering support for continuing or expanding the range of 4-meter telescopes that we have access to, which would have, the 4-meter telescopes are often the most oversubscribed worldwide. And so I think it's not just astronomers who are interested in this. The problem is we want the telescopes and we want all the time on them, of course.
Yeah, we found in simulating those surveys that the 4 meters were a very nice meeting point of, the amount of time you want to spend on the star to help average over pulsations and the signal of noise that you want to get to, where neither one of them is vastly outscaling the other. But as you say, they are, in high demand.
I do now want to follow up to what Megan said. I understand the premise of having like a public repository, but from like my experience running the ESSP and also like coordinating between the solar telescopes, there's a lot that you lose when you give your data off to someone else and you're no longer interfacing directly with the person who produced it. So like a lot of the things I did with the ESSP, I had to draw on the fact that like I wrote the pipeline and I helped align the spectrograph and I took most of the data myself, right? And in a lot of ways I was able to help people deal with the data and the tricks of that. And so if you put them all in the same, and it encourages this interpretation that all of the RV data is similar in specific ways without understanding the differences about the instrumental variations in the background. And it would be, I think, peculiar to some people to have NASA be hosting that when NASA hasn't built any of the instruments that are producing the data.
NUIT is a NASA instrument from NASA's point of view. NASA did not build it. That is absolutely true. But I hear what you're saying. Yeah, I think NASA is willing to fund supporting the archive. That's what NexI does in large part right now with the Kepler or the exoplanet archive and things like that. So that is an expertise they have that they were like, we could help in this way. And so whether or not that's where we want the data to live is a different question. But yeah, a thing that I would love to see more of, because I think you're exactly right, and this doesn't fully solve the problem, but is more, I think people are getting better about tutorials, kind of background reading for if you're going to use this data, here's what you absolutely need to know about it. But I think those kinds of supporting documents as well are really valuable and something that getting folks to invest time and effort into can be challenging because you made it work and now you want to move on to the next thing. But to help support broader community use, I think it's a good use of time.
I don't really think you know what you need to know until it breaks, but it's
that's fair. I'm saying this the benefit of you have hindsight because you've been doing this for a year and now you're going to make all these things public. What have you cumulatively learned over working with that data?
And I guess one of the thinking about the way that NUIT is doing things about its standard star data is public straight away, right?
And the solar data.
And the solar data, yeah. So I do think not only is it nice to have control of the data in the sense that if you build the instrument you understand it better, but there is also a level of well, if you built the instrument you should have a bit of time to be able to look at the data and be rewarded for it in that sense. I'm not completely opposed to having proprietary periods for things, but maybe there is this maybe NUIT has a nice balance of some of it.
Yeah, their GTO time has a proprietary period, which is a couple years, I think. But the standard stars and the solar data was public immediately.
Yeah.
They kind of lean towards the test model of this is for the community and more science will come of it.
If people have ideas about the best way that we should approach that as a community, that would be useful. Is it?
Yeah, as a slightly different point, I guess as someone who measures a lot of masses, but it's not in any GTO and so applies a lot of times. I think what's still missing a lot is good predictable, good tools that can predict, how good data will be ahead of time. We've heard a bit yesterday on the young stars that there are some tools, but that they don't always seem to work or are not always necessarily reliable. And part of the problem is that often these kind of things are justified inside proposals rather than in sort of public papers, right? We write those things. When we write the proposal, we make some calculation or make some justification inside a proposal rather than in sort of a white paper or in terms of public tools. So I think there's lots of things already happening, but I think there's still a big part there in terms of open software or white papers or tools in terms of, convincing people not in this room what can or cannot be done before you get the time.
Yeah, Jen, put the word forecasting in there. just kind of communicates with other communities.
Yeah.
Regarding the data and the way that we consider data that was taken using other instruments or whatever, I think that software is also a technology. And we are very much invested with money and time in building up instruments. But one thing that I take from here that forefront of the field is astrostatistic and software. And we need to design it together. And we cannot do it without good access to data. So keeping all the data inside of the instrument, I think it's not a good recipe for the long run. I get the motivation. It's very hard to do progress in a good way like that.
Yeah, definitely agree with that.
I just want to say something here is that as involved in a team where we build radial velocity instrument, like you don't just build a radial velocity instrument and then you have your radial velocities, right? So it takes, I don't know, Espresso was in all the project, it was 40 million, taking into the people and so on. It was more than 10, 15 years. And we are still working now. A lot of people in Geneva are working on the pipeline on this. So, okay, you do this and then you open all your data. It's a tricky balance, right? Because you still have to acknowledge the work that has been done behind. So it's why it's also, we have this trade-off that we don't really want to share directly the data and so on. But for example, on ESO side, so Espresso, okay, there is a GTO, data are proprietary for 5 years for the GTO. But then for all the other programs that are using Espresso or HARPS, the proprietary time is 2 years. So then basically now you have all the data since from 2003 to 2020. So there is a lot of data there.
And I wonder if
and some of the programs are shorter. You can, when you apply for time, you can say.
You can even say less than 2 years if you want. So. Yeah.
And all my data is public.
I guess maybe we think back to what Hogg said. What was it? The cosmology example. It sounded like they were like a bit afraid to like open it up, and but actually opening it up just made it better, and it made the work more powerful that they had put into it.
I get the point for sure.
Yeah. And I wonder if it's a case where something like this set of, standard stars, where standard is not necessarily EPRV quiet, but like let's define a small library of stars, and that data goes out to the community on near real time, and then everything else that has like specific science focuses is yours for whatever your proprietary period is, might be helpful.
But that is actually the case for Espresso, right? We just don't really do that with the standard stars.
Okay.
Yeah, when we talk about standard stars, so before me. Just because you mentioned standard stars then, do we need to review, like some point quite quickly, about an agreed set of standard stars? Because I know HARPS 3 terra hunting really wants to do a sort of small set of stars that we can, like say, collect a global network of everyone looking at those stars. But if we recognise that the classic spectroscopic standards are maybe not what we necessarily want to be looking at for EPRV, different things aspects we want to be looking at, then do we need to rapidly review that so we can all switch to?
I think that's a great action item, and I would love to see, this is what we proposed for StarSpot, was to do this like grid of stars where we had FGKM, low, medium, high activity, and we wanted like at least 1 or 2 stars in each grid square to say, here is a library where no matter what you're observing, you can find something kind of akin to it in here and have a nice data set to compare to. And so, yeah, I think the tradition of like, we'll observe Sigdraw and Tau Ceti because we don't think they do anything is, from all the work we've seen this week, maybe not actually what we as a community want to move our methodologies forward. So I think that's a really important conversation to have and one that should be in the near term.
Yeah, cool. Or even the very near term, we can decide. I think HARPS 3 would like it to be in the very near term.
Yes, I mean, that's thing we wouldn't be able to do necessarily all the same because, we can't do M stars and things like that. But, if there was like a set, then we could do it.
Suzanne?
I think what I was going to say is kind of being covered. This idea that it would be great to identify a small number of stars apart from the sun that multiple instruments try to look at. And I was interested by the points that Lily and Xavier made about the importance of how do we mesh the fact that we want open data as much as possible, but we also need the experience of the people that have built and calibrated the instruments. And so I think that that tells us that this kind of community building exercise has to involve people as well as website. And so that the kind of tools that allow us to keep in touch with each other, whether it's Slack or some other methods, I think they play an especially important role here. But I would also, it's easy for me to say this because I'm not part of a team that develops instruments, but I suspect that the more the data is open, the more use is made of the instrumental data. And it's so the idea of having setting aside a number of targets to be proprietary is fine, so long as among the targets that are not set aside, there are some that are as intensively observed. So we need, because at the moment, for example, if you look at the public espresso data, I think it's relatively few observations per target, or the time sampling is not what's needed. So that's going to be the.
But even the newest standard stars, I think the cadence is like once a week, which is below what I think we would be hoping for the kinds of studies that we want to do.
Thinking off the top of my head about this idea of like, how do we go forward and balance the effort that has gone into building and making the software and the instrument and the open data thing. Maybe we need to rethink about how we publish, in the sense that okay, if they want to, most of us actually don't care if you tack on an extra number of authors. After you've got more than 3, it doesn't matter, and say some subset of people contributed heavily to the instrument or the software or something, and then they've made their data open. What they really want is the citation. At the end of the day, they want to be credited for that effort. And so maybe we need to think about a way of okay, I'll use this open data, but rather than just saying it's open data, I don't have to bring them on the paper. We bring them on the paper in some way. I don't know if it's if you join the EPRV network, that is somehow an affiliation, and then you merge that into how we publish. I'm not sure what the solution is there. Aries?
I really think taking a leaf from how Tess has done it is probably a really good way to go forward, because they do exactly that. There's the 9 Tess architects who end up on every Tess paper because they, did most of the work to get it up there. And then what I really like about it is the fact that when you start working on a target, you can seek approval to, work and publish it from one of the people who oversees it. And then you put it on the public test forum and you're okay, I'm working on this target. Does anyone have any data? Do any people want to be co-authors? And it's a really good way to avoid 2 separate groups working on the same thing and then one ending up scooping the other accidentally. And I just think it's a really good way to foster collaboration. And for my first paper, we avoided a conflict between 2 separate groups through the way Tess does it.
Suzanne? No, I was just going to, you mentioned this idea of essentially having architects who get credited, and I think we should always offer this to the people who built the instruments and the pipelines by default. It's the least we can do. But it may also be that people don't particularly want to be pigeonholed and only have the opportunity to work on the instrument and the pipeline and never on the science. And I would say actually it should go the other way around too. And it's extremely valuable for somebody who mainly works on data analysis to spend a few years at some point in their career getting really their hands dirty with the data. I would encourage, and I think where we need change to enable that to happen is in the way we evaluate people's careers.
I really like that, Susan.
Yeah, and just piggybacking on the way we think about careers, one of the things that we didn't mention, but is in that EPRV final report, was advocating for more long-term postdoctoral and fellowship positions. So in Europe, there are some positions where you can have 5-year fellowships, whatever, but there's a lot of positions that are 2 years or 3 years or 18 months or something. And once you get to a place, then all of a sudden you have to apply to go to the next place. And then you spend so much time applying, you don't get to dig into the data. And so I think that is another area as a community where we need to rethink how we structure careers going forward.
I don't want to lose in this this conversation things that Tahar and Xavier said, which is that instruments are integrated software hardware systems. And we often think of them as hardware. There's hardware and then there's software. And there's an old way of thinking about an instrument where you build the hardware as well as you can and then build the software to match, which I think is over. I think we now build hardware in the context of what we know software is capable of and so forth. And that means that the community building software is actually helping the hardware teams in the long run. And the hardware teams get, and so I don't want to lose in this conversation, though I absolutely agree, hardware people must be protected, and I agree, and I know good models and bad models, but I think the work that the community does exploiting the data sets that are out there helps the hardware team as well, and it's important not to forget that.
So, yeah, for example, on this side, I don't know, so I work on Hopsnow, Precursor, also on the pipeline behind and everything. And often people that analyze data comes to us and say, there is a problem doing this night, can you check for it? Of course, they don't have the knowledge of everything that we have and so on. But often we say, okay, but just check the signal to noise, just check if the velocity per orders is okay, and try to investigate a little bit more into the thing, rather than saying, oh, my radial velocity and have an offset, and where is it coming from? Because then we cannot do everything. And my impression often is that I do like 80% of checking why data are not good and so on. And that all my science is on the side, and I would like to do more science.
Maybe we
should
need
work on that issue.
maybe we then sort of need written down somewhere for people who know less of like what are the things that they should check before they come to you. So that kind of thing, like something we can put in this on the website for this coordination network or something. Like,
yeah, but they're like the same point I feel like, because like the hardware and the software people have to be supported in the same way. Because when you write a software, you build an instrument, suddenly like 80% of your job becomes supporting that software, supporting that instrument for people who aren't digging in, and you don't get paid for that aspect, and you scramble to do science that will get you the next job.
Yeah.
And so like if you suddenly make your data open to everyone, then those are the number of people you will now have to respond to emails to ask you like, why is this specific order looking weird on this night at this hour?
Yeah, and NSF would not give you money to do that.
Yeah.
And like the software group, like Dan Foreman-Mackey is running a workshop discussing this at the CCA, and they're facing the same problems. And it's like a huge question that I think the field of science has to address.
So we need to foster self-help. I mean, to some extent, cheat sheets help, but if they don't.
I guess we're probably past doing 1 hour. I don't know how you want to.
Well, I was going to say maybe if we wrap up at 1:45, just because the food's probably waiting for us. Okay. We do have the room this afternoon if people want to stay and informally discuss.
And I will say this document is going to stay live. I was going to try and synthesize it into a write-up of some sort, next week once I've recovered from jet lag back in California. But if you have other thoughts or ideas that come to mind, please feel free to just add them in here. And with, parentheses for more context, if that's helpful, or put it in the Slack. But I'll try and grab all of the things that we've talked about and put them into a readable format. Okay, we've got 4 minutes. Anything else folks want to get on the list while we're still here in person?
Oh, there are some comments online.
Oh, right.
Eric Ford mentioned, while I'm open for data and open science, I would caution that there is some risk of groupthink, for some big projects like LIGO or
Also that.
they intentionally organize separate subteams to analyze data separately and make sure the conclusions are actually robust.
Okay.
Finding F 2.0 is up there, is in the importance of not becoming an embarrassment for all science. So I hope that we can think of how to combine open data with strategies for making sure results are truly reproducible.
I think that's a great idea, and having, teams focused on slightly different aspects of it, or even on the same aspect, but working independently and then being able to cross-check their results. I think it's going to be really important because, if it's all done in one single effort, one way, then the cross-validation idea falls apart real fast.
So maybe for one of the very near-term goals, we can make a list of like the different aspects, like the pipeline or the RD development, template matching versus line by line, and figure out which groups are already working on it independently, because that was one of the biggest things I learned from ESSP, like how many people are approaching it in the same way and just aren't talking to each other.
Yeah, I think that's important. That could be like you have a page that is like what are the upcoming meetings and stuff, but then the page is also like who's working on what and what and they can decide to the level that they want to share what they're working on.
This is a thing, when you sign up for the RCN, I ask you to provide like a couple sentences about what you focus on, and then I'm gonna make a color-coded directory that's like, if you're looking for a person who thinks about X, you can search there. It won't be as detailed as you want it to be, or like as would be most useful, but it'll at least be a starting point. Just reinventing the yellow pages, it turns out. Yeah.
On this note, I don't know if we brought it up explicitly, but like working in the near infrared versus the visible, that wavelength coverage, I would really love collaboration across that as well. We've really talked about software, hardware, and stuff like that, but I think there's generally a big divide between the visible and the near infrared right now. Like I brought it up, or like people talk about visible stuff, and I'm like, I know what those spectra look like, but then I just go blank, and then I'll bring up near infrared, and they're like, I don't really know. It's caloric, stuff like that. But there's definitely some collaboration that could go on to bridge that gap and then, go beyond the chromatic.
A thing we want to do is do a series of half day, 3 to 4 hour workshops on different topics and try to invite people to do competition kind of like this, of talks but then discussion sections. So it'd be some part tutorial, some part overview talk of here's the problem we're facing, and something like this I think would be perfect for it. How do we, leverage the interactions between those two types of data and those two communities.
One thing that I thought we could use the Slack, since it's going to continue existing for, is if any of us leave this thinking, now I'm going to do something that I didn't think I was going to do before the workshop, please write it down in the Slack so we know. First of all, so we can say to our funders, look, we did this and good things happened, but also so that we know, because if we had a bit the same idea, we know who to get in touch with.
Suzanne, is there a acknowledgement sentence? Because I know that's often how we track if a grant was useful, so you can search on ADS for the text and just say, we acknowledge EPRV. Is there a static sentence you'd like people to include if papers come out of this?
I say that when we do the Gaia sprints and other meetings like that, we write a 1 or 2 sentence thing and we ask everyone to say it in their papers. Yeah. That's great because we can literally do a web search and count the papers that came from the Gaia sprints. So I hereby volunteer to give you that.
Please do. And then I'll put it in the Slack. And then
we'll put it in the Slack, but also email it because, different levels of attention.
So that was going to be another question for everybody. So I have a Google Sheet with all the people who participated in this workshop, their names, affiliations, their emails, online and in person. I have shared it with you guys. How do people feel about me actually putting that on the website so that it's more widely available? I'll post a link on Slack as well.
I might ask to swap out. I gave you my Gmail. I'd rather have my JPL email on there for the world to see. So if you don't mind just checking that out, that'd be great.
So what I'll do is I'll share the edit link on the Slack so that people can make sure it's all as they would want it to be. And then yeah, sounds good.
Okay, we have hit quarter till, and so we should maybe wrap this up.
Well, thanks.